Assalamualaikum and hi everyone. Okay, so today I'm going to teach you how to determine the cumulative distribution function for your continuous random variable. So I'm going to start with the example 1. It's okay. So as you can see, given here, the first one is a function with small letter f and the second one is the big letter f. So what does it mean with this one? Okay, so the small letter f is actually referring to your probability density function, okay, or sometimes we refer it as PDF, which means probability density function, whereas the function with big letter f or capital letter F is actually using for cumulative distribution function, okay, or sometimes we refer it as CDF. Okay, so actually, okay, normally in the questions or in the exam, they will give you the probability density function, and from the given probability density function, you need to find out what is your cumulative distribution function. Okay, so how are you going to determine your cumulative distribution function from the given probability density function? Okay, so it's by using the integration process. So to transform from your probability density function 1 over 10 to your cumulative distribution function, you're going to use integration process. Okay, so can we transform back your cumulative distribution function to probability density function? Definitely yes, by the reverse process of integration, which is differentiation. So in these examples, I already derived to you what is the cumulative distribution function from the given probability density function. But I'm going to show you and prove to you how do we get this cumulative distribution function as seen in the screen. Okay, so first, we need to find out, okay, what is the cumulative distribution function when x is less than 0. So first, when x is less than 0. Okay, as you can see from the probability density function, when your x is less than 0, okay, your fx, your probability density function is equal to 0. Okay, so therefore, okay, integrating from t to negative infinity with 0 dx, it becomes 0. Therefore, your cumulative distribution function is equals to 0 at x less than 0. Okay, next, let's find out what is the cumulative distribution function with the class interval from 1 less than x less than 11. Okay, so the given probability density function for this class interval is 1 over 10. Okay, so therefore, the fx is you're going to integrate 1 over 10 dx. Okay, what is the value of the limits? Okay, so the lowest limit should be 0. Okay, so the lowest limit should be the lowest limit in the class interval, which is 1. Okay, and the largest limit in this one should be t. Okay, because it's within the class interval 1x to 11. Okay, so when we integrate 1 over 10, we top x, so it becomes, we're going to add 1x, so x over 10 t and 1. Okay, so we're going to find out what is the new cumulative distribution function. Okay, so when your x is replaced by t, so it becomes t over 10 and minus, when x equals to 1, it becomes 1 over 10. So this is the cumulative distribution function within the class interval 1x and 11. So we're going to rewrite it again. So the variable that we use is only x, as this is function fx. So x over 10 minus 1 over 10. Okay. And thirdly, we're going to find out what is the cumulative distribution function for fx, which is greater than 11. Okay, so third, okay, fx for x greater than 11. Okay, so from 0 to negative infinity, we have, which is this one. Okay, so 0, from 0 to negative infinity, dx plus integrate, okay, between the class interval of 1 to 11, which is 11, 1, which is we have 1 over 10 dx, okay, plus greater than 11, which means we have 11 t 0, okay, because the probability density function for x greater than 11 is 0 based on this statement otherwise, okay. So integrating 0, it becomes 0, plus integrating 1 over 10, it becomes x over 10, and the class limits is between 11 to 1, and again integrating 0, this one become, and integrating 0 for this one, it becomes 0 too. So we leave out with x over 10, okay, for the class interval between 11 1, which is equals to 11 over 10 minus 1 over 10. Okay, we simplify this, we get 10 over 10, which is actually equals to 1. Okay, so therefore we get fx is equals to 1 for x greater than 11. Okay, so we already find out for all the class interval involved. So now we're going to write it down. What is your cumulative distribution function? Okay, so therefore the cumulative distribution function for this probability density function is equals to 0 for x less than 0, okay, equals to x over 10 minus 1 over 10 for the class interval between 1, x and 11, and 1 when x is greater than 11. So this is your cumulative distribution function. Okay, what about if the question asks you to sketch the graph? Okay, so y-axis should be your cumulative distribution function, and your x-axis should be the value of your x, which is your variable. Okay, so when x is less than 0, the value is 0. Okay, so that's okay. And when x equal to 0, it means it's 0. Okay, as you can see, the cumulative distribution function for the class interval 1, okay, 1, x and 11 is just was 1f, so that means this is a linear function. Okay, so we're going to find out what is the value of fx when x equals to 1. Okay, so 1 over 10 minus 1 over 10 equals to 0, and when x equals to 11 equals to 11 over 10 minus 1 over 10, which is equals to 10 over 10, and simplify equals to 1. That means at x equals to 1, okay, and x equals to 1 and x equals to 11. Okay, so when your x equals to 1, your fx is equals to 0. Okay, and when your x equals to 11, your fx equals to 1. Okay, so we're going to connect the dots. Okay, so this one 0. Okay, then a straight line, okay, to 1 at x equals to 11, and from the cumulative distribution function, your fx goes to static at number 1 when x is greater than 11. So continue a straight line from 1. Okay, so this is the graph for the CDF. Okay, so we're going to move on with the next example. Okay, so we're going to move on to the second example, which now we have two different probability density function for two different class interval. Okay, so definitely it's 0, sorry. Okay, it should be 0 for otherwise. That means other values there which x less than 0 and when x is greater than 5. Okay, so this is the given probability density function, your PDF. And we need to find out what is the CDF, your big F, for this one. Okay, so first, as usual, since your CDF, okay, so your CDF is defined from, okay, which is the lowest limit is negative infinity and highest limit is t. I'm going to use letter t, which later on I'm going to replace it with x, and this one is your fx dx. Okay, so therefore, firstly, okay, Okay, we're going to find out what is the CDF, your cumulative distribution function, when x is less than 0. Okay, as you can see in the given probability density function, okay, so as you can see from the given probability density function, okay, it is equals to 0 when otherwise, that means any values of x other than given class interval, which is these two. Okay, so therefore we're going to integrate this one, okay, equals to, which is from t to negative infinity 0 dt, 0 dx. Okay, so it's equals to 0. Integrating 0 means equals to 0. Therefore, your fx equals to 0 at x less than 0. Okay, what about the first class interval given in the probability density function, which is from 0 less than x less than 1? Okay, so we're going to integrate, okay, which is from 0 to t, okay, for the function x squared dx. Okay, so integrating x squared, your x power will increase by 1, which is 2 plus 1 equals to 3, and we're going to divide, okay, we're going to divide this x cubed with the new power, which is 3. So close the bracket, t 0. So we're going to find out what will be the value when we replace the x with t. So it becomes t cubed over 3 minus, okay, replace 0, so 0 cubed over 3, which is definitely equals to 0. So therefore, your fx equals to actually t cubed over 3, okay, which we're going to replace t with x, so it becomes x cubed over 3 for 0 less than x less than 1. Okay, so we're going to show you how to determine the new cumulative distribution function for this another class interval. Okay, so the third one. Okay, so between class interval of 1, x and 5. Okay, for this new class interval, given your fx is equals to 5 minus x over 12, okay, for 1x5. Okay, so I'm going to simplify this function to become 5 over 12 minus x over 12. Okay, so I'm going to integrate this one to get my cumulative distribution function. So my big fx is equals to, okay, so I'm going to add on, okay, from the previous class interval, which is, okay, below than 1, we have 1 to 0, and the given probability density function previously is x squared dx, plus with the new class interval, which have the function of 5 over 12 minus x over 12. Okay, so the lowest value for this interval is 1 and t for the highest value. Okay, so integrating x squared, so it becomes x cubed over 3 1 0, okay, plus integrating 5 over 12, so it becomes 5x over 12 minus x squared over 12 times 2 is become 24, so t1. Okay, so how I'm going to solve this? So this one, I'm going to replace x with 1, so it becomes 1 over 3 minus 0 over 3 for the first one, plus, okay, so the second one, okay, first I'm going to replace it with t, so it becomes 5t over 12 minus t squared over 24. So I'm going to subtract it with, when I replace the x with 1, so 5 over 12 minus 1 over 24. So 1 over 3, and this one, if I'm going to simplify it, okay, so it becomes 5t over 12 minus t squared over 24, and it's going to be equals to minus, okay, 3 over 8. Okay, I'm going to simplify further for this one. So your fx becomes, okay, 5t over 12, okay, minus t squared over 24, and minus 1 over 24 for this class interval, which is between 1, x and 5. Okay, so lastly, we're going to find out for the fourth class interval, okay, which is when x is greater than 5. Okay, so when x is greater than 5, we already covered two different cumulative distribution function. Oh, sorry, three cumulative distribution function, which is from x less than 0, okay, from 0 to 1, as well as 1 to 5. Okay, so that means we're going to add up all, which is equals to integrate, okay, from 0 to negative infinity, which is 0, plus from 1 to 0, which is your x squared dx, plus, okay, which is 5, and then 1, which is the function is 5 over 12 minus x over 12 dx. Okay, so equals to 0 plus x cubed over 3 for 1 0, okay, and 5x over 12 minus x squared over 24 between the limits 5 to 1. Okay, so 0 plus 1 over 3 plus. Okay, so if you calculate, when you replace your x with 5, so it becomes 25 out of 24. Okay, going to minus when my x in this one equals to 1. Okay, so the values becomes 3 over 8. Okay, so I'm going to simplify this one. So it becomes 1 over 3. Okay, plus with 25 over 24 and minus 3 over 8. The answer should be 1. So your cumulative distribution function is equals to 1 for x greater than 5. Okay, after you get all the values or the functions of cumulative distribution function for these class intervals, so you need to summarize them up and write down the cumulative distribution function, okay, in one. Okay, so your cumulative distribution function is first equals to 0 when x less than 0. Okay, secondly, it's equals to x cubed over 3 minus 1 over 3 for class interval for 0 less than x less than 1. And thirdly, okay, so it is 5x over 12 minus x squared over 24 minus 1 over 24 for class interval 1 less than x less than 5, and lastly equals to 1 when your x is greater than 5. Alright guys, thank you for watching. See you guys in my next video. Bye bye.